Hi guys, today I am here with an important topic that is called sulfur halide. In this video we will discuss the types of sulfur halide, their reactivities and previous year question from this topic in different competitive exams like CSIR-NET, GATE, etc. So mainly three types of sulfur halides are prepared, that are Me2S CH2, that is called sulfonium halide. Here it will be plus minus. This is called sulfonium halide. Another type is Me2S. This is called sulfoxonium halide. And the third type, that is this is called sulfone halide. Now if we see the pK value of one series, that is called that is CH4, which has pK value 65, then if we attached one pHs group with this CH4, then the pK value of this compound decreases from 65 to 48. Further, if we add one oxygen in this sulfur, then this compound has pK value 35. Further, if we add another oxygen in this sulfur, this is CH3, then it has pK value 31. And if we replace one CH3 with pH, then it has pK value 29 in DMSO. These are pK value in DMSO. So you can say that this anion, that is the conjugate base of this acid, CH2 minus will be the conjugate base. So these are much more stable than this. So we can say between these three ylide, these two ylide are much more stable than this, because here the oxygen atom will come in resonance and here two oxygen atoms are there, so here the resonance will be much higher. So these two ylides are much more stable than this. But if another electron withdrawing group like CN or COOET group attached with this CH2 CN, let's say, or Me2 COOET, let's say, these compounds are also stable, because here the negative charge will come in conjugation with this electron withdrawing group, so then the ylides become stabilized. Now we will discuss the general reactivity of ylide. Let's say if we take one alpha beta unsaturated carbonyl compound like this, and if it is treated with Me2S CH2, that is sulfonium halide, and in another reaction if it is treated with Me2S CH2CN, CHCN, then what will be the product? If it is treated with Me2S CH2 minus, that is a non-stabilized halide, whereas it is a stabilized halide. With a non-stabilized halide, mainly the reaction will happen in this carbonyl group, whereas with stabilized ylide the reaction will happen with this site, that is 1,4 addition will take place, whereas with non-stabilized 1,2 addition will take place. So how the reaction will happen? For non-stabilized ylide, it will attack into this carbonyl carbon. Now SME2 plus is a good leaving group, so it will attack into this carbon and simple SN2 reaction will take place. So SME2 will remove and the product will be an epoxide ring will be formed here. On the other hand, the reaction with a stabilized ylide it will attack into this center. It will attack into this center and here 1,4 addition will take place. CH here CN SME2 plus. Now it will come back and it will attack, it will attack here and SME2 will remove. So the product will be here, a 3-member ring will formed, a cyclopropyl intermediate will be formed. Here a pH is there and here 1 CN. So that will be the product. Now in another reaction, if we take this ylide Me2S COOT, that is a stabilized ylide with a compound like this alpha beta unsaturated ketone, and in another reaction we are taking this. So what will happen here? Here no alpha beta unsaturated ketone is there, two beta diketone is here, alpha diketone. So what will happen here? Here with a stabilized ylide also an epoxide will be formed, because no question of 1,4 addition will take place here. On the other hand, here with a stabilized ylide only 1,4 addition will take place and the corresponding epoxide will be formed. So here the product will be COOT, this will be the product. On the other hand, here the product will be COOT and so that will be the product. Now we will come to the chemoselectivity of this ylide. That is why with a stabilized ylide 1,4 addition will take place and why with a non-stabilized ylide 1,2 addition will take place. With a non-stabilized ylide, it will mainly attack at 1,2 position, and this reaction is fast and irreversible. Fast and irreversible. So O minus CH2SME2. As this is fast and irreversible and it is a good leaving group, so now it will attack here and it will eliminate. So the product will be an epoxide. But why it will not attack at this position? Because this is more electrophilic than this position, because here directly oxygen atom is connected, so it will mainly attack into this position, this carbonyl group. So this reaction, this 1,2 addition will take place fast and irreversible manner. On the other hand, the reaction will take place here also, but this will be very slow, so the product will end up as an epoxide. On the other hand, if we take one stabilized ylide, then what will happen? If we take one stabilized ylide, then what will happen? So here the reaction with this carbonyl compound is also fast and it is reversible. Why it is reversible? Because here the ylide is here the ylide is a stable compound, and also the carbonyl group this is also stable. So if it will attack here, the compound that is formed SME2 plus, it is quite unstable than this, so the reaction is reversible and the product will decompose to starting material. On the other hand, if attack occur in this position, that is 1,4 addition will take place. If 1,4 addition will take place, then this is slow but it is irreversible. This is slow but it is irreversible. Slow but irreversible. But as it is irreversible, so the ylide will used up here and the reaction will go to completion. So the here it will attack. SME2 plus CWT, it will attack here, so it will remove and a cyclopropyl intermediate will be formed. So the reaction will go to completion here, but as this is reversible, so it will attack and the this will be formed, but with respect to the starting material this is unstable, so it will decompose to the starting material again. So this is a thermodynamically controlled product and this is a kinetically controlled product. Here one thing you have to remember, that in the reactant there is a keto group and there is a double bond here, but here in the product the keto group is intact, but in product 2 sigma bond is formed at the expense of one pi bond. So as the pi bond has lesser energy than the sigma bond, so the product is more stable than the reactant. So this is thermodynamically more stable. Here thermodynamically this product is favorable. So that's why the 1,4 addition will take place here. Now we'll take one example. Let's say the substrate is this, and what will be the product if it is treated with this and in another reaction this. So what will be the product? Now as you can see here that this is a stabilized ylide, whereas this is a non-stabilized ylide. So with stabilized ylide only one partition will take place, that is thermodynamically controlled product will be formed. So an cyclopropyl ring will be formed here. On the other end, in this case epoxide will be formed. Here the attack will be on carbonyl compound. So the product will be this. So guys, in the next video we'll discuss the solved problem from competitive exam. And if you have any doubt regarding this video, please let me know in comment box, and to get such interesting videos subscribe my channel. Thank you, have a good day.